Okay, so I saw this number, $456.2 million projected for 2025 for air bubble detectors.
Yeah.
And I thought, what are these exactly and
Yeah.
why such a big number? Sounds specific, but maybe it's more critical than it sounds.
That's exactly it. It's the perfect way to start this deep dive we're doing today.
Okay,
We've been, digging into a recent market research report from Cognitive Market Research,
right.
and it really opens up this whole world around the tech. It's surprisingly complex and growing fast.
So this isn't just a guess. There's solid data behind this 456 million figure.
Oh, yeah. It's a pretty comprehensive report. It looks back 2021 to 2024. It gives us that 2025 number as a kind of snapshot, and then projects all the way out to 2033.
Wow, okay.
And it breaks down, well, pretty much everything. Market size, growth rates, regions, the different product types, the tech involved.
Applications, who's using them?
Exactly. Applications and users, the whole picture.
Right, okay. So our mission here then is to pull out the key stuff. Like what's really driving this market? Why are these detectors suddenly so important without getting lost in, endless charts and numbers?
Precisely. We want to give you that clear sense of why this market, which seems maybe a bit niche, is actually pretty significant, and what trends are really shaping it.
Okay, let's do it. Start us off with the big picture. What's the global situation and where's it headed?
Right. So the headline number is that 456.2 million USD for 2025. But the really interesting part is the growth projection.
Okay.
The report sees it hitting 670.3 million USD by 2033.
Wow, that's a pretty big leap. Not just slow and steady then?
Not at all. We're talking a compound annual growth rate, a CAGR of 13.20%.
13.2%.
Yeah, from 2025 to 2033. And, anything over 10%, especially over 13 like this, that points to a really strong accelerating market. It's picking up speed.
Okay, 13.2.
Yeah, that definitely gets your attention.
Yeah.
So where is this happening, geographically speaking?
Yeah.
Who are the big players right now? Well, right now, North America has the biggest piece of the pie, over 37% of the global market.
Okay.
Their number for 2025 is about $91.98 million. And they're looking at an 11.9% CAGR through 2033, which, makes sense with their established healthcare and industrial base.
So North America is the leader. What about across the pond in Europe?
Europe's number 2. They've got over 29% market share. That translates to about $72.09 million in 2025.
And their growth?
Their CAGR is pretty solid, too, 12.2%. So, growing steadily, right around the global average.
Okay, so North America and Europe are the heavyweights.
Yeah.
Is there anywhere else that's showing, really explosive growth?
Absolutely. That's the Asia-Pacific region, APAC. Currently, they hold around 24% of the market, about $59.66 million for 2025. But here's the kicker. Their projected CAGR is a huge 16.2%.
16.2, wow.
Yeah, between 2025 and 2033. So APAC is definitely the region to watch for the fastest expansion here.
That's way higher than the global average. Any idea what's driving that kind of growth in APAC specifically? Is it certain industries or maybe faster tech adoption?
That's a good question. The report suggests a few things. Big investments in healthcare infrastructure over there, for one.
Okay.
Plus, a growing manufacturing sector that's really pushing automation and quality control, and maybe just a faster uptake of, advanced medical tech in general.
Right. Upgrading systems, focusing on safety.
Exactly. And that directly fuels demand for these detectors.
Makes sense. What about the other regions? South America, Middle East, Africa, how do they fit in?
Well, South America has just over 3.8% share. That's about 9.45 million in 2025, but their CAGR is 13.6%, so growing slightly faster than average.
Good.
The Middle East is around 4% share, 9.94 million, with a 13.7% CAGR. Also strong growth potential. Africa's smaller, around 2.2% share, 5.47 million. Their CAGR is lower at 9.2%.
So even in regions with smaller market sizes now, there's still pretty significant growth happening. It's a global trend.
It really seems to be, yeah. A widespread increase in adoption.
Okay, so we see the where and the how much. Let's get into the why. What are the main things really pushing this demand up so fast? The key drivers.
The report points to a few key things. First, just plain technological advancements. The detectors themselves are getting better, more sensitive, more reliable.
Right.
Second, they're being used more and more in different industrial settings. Industries are realizing they help with efficiency, quality control.
Makes sense.
And maybe the biggest driver, just a growing focus globally on Product safety, especially in healthcare, but also manufacturing. People are much more aware.
Product safety.
Yeah.
Yeah, I can see that. Even a tiny bubble could be a huge problem in some cases. Are there any roadblocks, though? Anything that could slow this growth down?
Yeah, the report does mention a couple of potential restraints. One is simply cost. Some of the really advanced detectors are expensive.
Oh, okay. A barrier for some.
Could be, yeah. Especially for
Ah.
smaller companies or in markets that are more price sensitive. The other thing is, there are still some technical limits.
Technical limits. Like
Yeah.
what? Situations where they don't work perfectly?
Exactly. Things like, the type of liquid being monitored, how fast the bubbles are moving, maybe even the design of the pipe or tube. These can still be challenges for getting consistently accurate detection.
I see.
But often, those limitations are actually what spur the next wave of innovation, which leads to the trends we're seeing.
Ah, okay. So the problems drive the solutions.
Yeah.
What are some of those exciting new trends then? What's happening in detector development?
Well, a big one is innovation around wireless and portable detectors.
Oh, interesting.
Yeah, that
Wow.
offers huge advantages,
Yeah.
right? Flexibility, easier installation, remote monitoring.
Definitely.
And also we're seeing more integration into like automated systems, smart manufacturing, where you need that real-time feedback for quality and optimizing production.
Wireless and portable. Yeah, that opens up a lot more uses. Okay,
Right.
let's talk about the detectors themselves. The report splits them by product type.
Right, mainly into fixed detectors and flexible detectors.
Okay.
Fixed detectors probably have the dominant share right now. These are the ones built for permanent installation in critical systems.
Like the workhorses.
Exactly. Think healthcare infusion pumps, IV lines. Detecting tiny bubbles there is absolutely critical for safety, but also in industry where bubbles can mess up processes or product quality.
So fixed are the established, super reliable option for safety critical stuff.
hmm
What are the flexible ones? You said that was the other type.
Yeah, and interestingly, flexible detectors are pegged as the fastest growing segment.
Fastest growing. Why is that?
Their big advantage is adaptability. They're really important where the fluid path might move or change shape, or where you need sensitivity to flow variations.
Okay, like where?
Think flexible FAVI tubes, some diagnostic imaging equipment where fluids are moving around, even those tiny microfluidic systems in labs.
All right.
In those cases, you need a detector that can still spot bubbles accurately, even if the tube bends or the flow changes. That's where flexible detectors shine, ensuring things work right and preventing harm.
Fastest growing.
Yeah.
Yeah, that suggests a real need for that versatility.
Oh.
Okay, let's get technical for a moment. What's the main tech inside these detectors? What kinds of sensors?
The biggest share right now belongs to ultrasonic sensors.
Ultrasonic.
They basically send out high-frequency sound waves into the liquid. Air bubbles have different acoustic properties than the liquid, right?
Right.
So when the sound wave hits a bubble, it reflects back differently. The sensor analyzes those reflections to find the bubbles, figure out their size, sometimes even where they are.
So using sound to see the bubbles.
Pretty much, yeah. And they're really versatile, used in medical gear, chemical processing, water treatment, even food and beverage to make sure things are pure.
Can you give an example, any specific innovation there?
Yeah, the report mentions Sonatec's Sonaflow Co.56 Pro V2.0. It's designed specifically for medical tubing. It doesn't just measure flow rate, but it's also really good at spotting air bubbles in those standard tubes, which is a big deal for safety in things like life support systems. Even tiny bubbles are dangerous there.
Got it. A real-world example of ultrasonic tech improving safety. What's the other main sensor technology that's making waves?
That would be capacitive sensors. And this segment is expanding really rapidly.
Capacitive. How do they work?
They work on capacitance, the ability to store an electric charge. Air conducts electricity much less than most liquids.
Okay.
So you have two conductive plates. When an air bubble passes between them, it changes the capacitance between those plates. The sensor detects that change.
Ah, so the bubble disrupts the electrical field.
Exactly. And that's key because undetected bubbles can mess up readings in lots of systems.
Any examples of innovation here?
Yeah, there's EBE sensors plus Motion's Kappa test technology, introduced pretty recently, November 2024. This system is designed to be really robust, detecting bubbles reliably across different kinds of liquids, different types of hoses, even if there are small variations in the hose or setup.
So more reliable across different conditions.
Right. Makes it really suitable for tough industries like food processing, pharma, chemicals, where you need that consistent accuracy.
That sounds like a good step forward for capacitive sensors.
Yeah.
Okay, let's shift back to where these detectors are being used. What are the main applications?
According to the report, the biggest application segment right now is cardiopulmonary bypass.
Heart surgery.
Yeah, when the patient's blood is circulated outside the body during major heart surgery, the risk of air getting into the blood is super high then.
And that's incredibly dangerous, right? And air embolism.
Exactly catastrophic. So having ultra-reliable air bubble detectors is just non-negotiable for patient safety in those procedures.
Really highlights the life-saving aspect. Okay, largest share is bypass. What about the fastest growing application area?
That would be diagnostic devices.
Diagnostics.
Yeah.
How so?
Well, detectors are being built into more and more diagnostic equipment. Things like blood analyzers, hematology, serum tests,
Okay.
also infusion pumps delivering precise drug doses, and diagnostic imaging like ultrasound or MRI. In all of these, air bubbles can either screw up the results or, again, pose a risk to the patient.
So not just major surgery, but everyday diagnostics and treatment too. Is regulation playing a part here, pushing for better detection and diagnostics?
It seems so. The report mentions the EU's medical device regulation, the MDR 21/745.
Yes.
Implementation has been extended a bit, but the overall push for stricter safety and performance for all medical devices in the EU, that's definitely driving demand for better bubble detection and diagnostic gear.
Right. Tighter regulations force better safety features. Makes sense. Any other key applications mentioned?
Yeah, it also specifically calls out dialysis and transfusion equipment, infusion and parenteral infusion pumps sort of more broadly, and also various types of blood processing equipment. Basically, anywhere fluids are moving in or out of a patient or being processed, bubble detection is critical.
So the medical field really dominates the applications. Who's actually buying these systems then? The end users.
Unsurprisingly, hospitals and healthcare providers are the largest end user segment.
Makes sense.
As we've been saying, these detectors are essential for safe IVs, cardiology, oncology treatments, emergency care, dialysis, transfusions, you name it. Preventing air embolisms and ensuring correct fluid delivery is just paramount for them.
Yeah, given the sheer volume of procedures, hospitals would naturally be the biggest buyers. What about the fastest growing end user segment?
That appears to be diagnostic laboratories.
Labs. Why them specifically?
Well, think about clinical labs, research labs. They use lots of sample analyzers for blood tests, biochemistry, etc.
Right.
Air bubbles in those samples or reagents can lead to totally wrong results. So integrating detectors helps ensure the tests are actually reliable and accurate.
Inaccurate lab results. Yeah, that could have serious downstream effects.
Yeah.
So labs need that reliability. Any other major end user groups?
The report also mentions pharmaceuticals and biotechnology industries as important users.
Okay.
In pharma and biotech, you need incredibly precise fluid handling and absolutely no contamination, including air bubbles during R&D, manufacturing. It's critical for product quality and safety.
Okay, so heavily concentrated in healthcare and labs, but also crucial in pharma and biotech where precision is everything. What about the companies making these detectors? Is it just a few giants or more competitive?
The report paints it as highly competitive. You've got a mix of big global players and smaller, maybe more specialized or regional companies.
Any names mentioned?
Yeah, some key names that pop up are Intertech International, Piezo Technologies, TE Connectivity, Sonotech, who we mentioned earlier,
Right.
and Siemens.
Siemens, we heard about Sonotech's sensor. Does the report give any other examples of what these companies are working on, innovation-wise?
It does mention that Siemens filed a patent back in September 2022. It was for self-tuning bubble detector assemblies.
Self-tuning, what does that mean?
It suggests systems that can automatically adjust themselves, maybe for different fluids or conditions, to maintain the best detection performance without manual tweaking, specifically for diagnostic analyzers.
So making them smarter and easier to use accurately.
Exactly. It shows that ongoing push for more sophisticated and reliable systems.
Okay. Now, to make this even more real, the report has some country-specific data, right?
Mhm.
Can you give us a few examples of market sizes and growth in specific places?
Sure. Let's take North America. The U.S. market is projected at $72.57 million in 2025,
Okay.
with an 11.7% CAGR.
Okay.
And part of that growth is linked to the rise in chronic diseases needing ongoing treatment and monitoring.
Makes sense. What about Canada?
Canada's smaller, 11.04 million in 2025, but its CAGR is slightly higher at 12.7%. Report links that to adoption of advanced sensor tech.
Interesting. Different drivers even within the same region. What about APAC, the really fast-growing one?
Right. In APAC, China's a big piece, 25.06 million projected for 2025, with a 15.7% CAGR. Wireless tech seems to be a factor there.
Okay. And India?
India's current market is smaller, about 5.97 million, but the
Yeah.
growth rate is huge, 18.1% CAGR.
18.1. Wow. Okay, how about Europe, UK, Germany?
In Europe, the UK is estimated at 12.11 million in 2025, growing at 13.0%, linked partly to increasing surgical procedures.
Right.
Germany's a bit larger, 14.27 million with a 12.4% CAGR. There, it's tied more to integrating detectors into advanced infusion systems.
Got it. And maybe one or two examples from other regions?
Sure. Brazil and South America.
Right.
Well, 4.04 million market size, 14.2% CGR, driven partly by more emergency procedures needing careful fluid management.
Okay.
And in the Middle East, Saudi Arabia, 3.50 million projected, 14.0% CAGR. There, it seems linked to growing awareness about the dangers of air embolisms during treatment.
Those examples really paint a picture of how global this is, but with slightly different local drivers.
Okay.
Okay, as we wrap this up, what are the main takeaways, the big points to remember from this deep dive?
I think the key things are, one, this is a surprisingly big market and it's growing really fast.
Right.
Two, that growth is driven mainly by safety concerns, especially in healthcare, and by constant tech improvements.
Mm-hmm.
Three, while North America and Europe are the biggest markets now, APAC is where the fastest growth is happening.
Okay.
And four, the main uses are definitely in healthcare surgery, diagnostics, infusion, but also labs and pharma biotech are important and growing segments.
And for you listening, understanding this, Air Bubble Detector Market really gives you a window into some critical stuff.
Yeah.
Healthcare safety, how sophisticated medical devices are getting, and those broader trends like automation and quality control that affect lots of industries.
Yeah.
It shows how a technology that sounds quite specific actually plays a really vital role.
Exactly. And it makes you wonder, doesn't it, as this tech keeps getting better, smaller, maybe smarter, what completely new uses might pop up? Could we see these detectors becoming crucial in fields we haven't even thought of yet, way beyond today's healthcare and industry applications? It's definitely something interesting to think about where this could all lead.